Hi, welcome to the 50th anniversary of Earth Day and what is now known in the American Chemical Society as Environmental Chemistry Week, and it's sponsored by the American Chemical Society. Such, I'm going to demonstrate an activity that can be performed by students from K through 12th grade using materials that are found around the home, particularly kitchen utensils, water, salt, and rubbing alcohol. 70% in particular, along with pieces of plastic cut out from materials that are normally recycled. The activity that I'm going to perform today is from a laboratory that I developed about 20 years ago. The premise is that some criminals performed an illegal activity and left behind some plastic material remains. There are as it turns out, 7 different types of plastics that are manufactured now. And so we have 7 suspects, each one of whom uses a different plastic. Our job is to identify which plastic was used in the activity, and this will help to determine which is the culprit in this particular deed. The technique that we're going to use is based upon the fact that the plastics, each of the plastics has a different density, and that by using appropriate liquids of differing densities, the plastics can be distinguished by the fact that they can either float or sink in that medium. So let's talk about the types of plastics that we have. Of the 7 that are available, I was able to obtain 6 of those. One of the techniques that I use is to take a bottle that was used but no longer in use, and carefully cutting out bits and pieces of the plastic. So this is one of the devices that was used, and as it turns out, this particular plastic is in the recycling code is number 1, and it's known as PET, or polyethylene terephthalate. So I have labeled in this bag some of number 1. And then number 2, HDPE, which is high density polyethylene. I was unable to get number 3, which is vinyl. That was not found around the house. Number 4, low density polyethylene, which is LDPE. Number 5, PP, which is polypropylene. Number 6, polystyrene, labeled as PS. And number 7, which is a mixture of other types of plastics. So this is everything else. To prepare the solutions, I took some tap water and put some table salt in it, shook it up, and made a solution that's saturated. Its density, the density of the solution is a bit greater than that of tap water. It's about 1.1 grams per milliliter. And to get the optimum density is to keep adding salt and then shaking that container while sealed. And as long as there's some salt remaining after a number of trials, you have a saturated solution of that. The second of the solutions I have in this container, and this is just tap water. The density of tap water is very close to 1 gram per milliliter. And then to get intermediate solutions, I'm going to mix. I can take some of the saturated salt solution and add a little bit of water to that and slowly bring the density somewhere between the salt water's density, which is 1.1 gram per mil, to that of tap water, which is about 1 gram per milliliter. And then to get a much lower density, I'm going to use some rubbing alcohol, which is isopropyl alcohol, and in particular 70% isopropyl alcohol. And that can be easily obtained. You might even have that around the house. And then to make an intermediate density, I can mix either 2 tablespoons of water with 1 tablespoon of the isopropyl alcohol, and then to get to get another solution, I can mix 2 tablespoons of the water with 2 tablespoons of alcohol to get a slightly lower density. So I can get a number of different solutions, and from that I should be able to distinguish amongst the various densities of the plastics. So we're going to take a look now at how to do that. We're going to start to distinguish amongst the plastics by first using some salt water that I mentioned. And I'm going to pour some salt water in there. And I'm going to first take my number 1 plastic, which is polyethylene terephthalate, and I'm going to put that in the water, and I'm going to push down with a utensil. I'm just using a plastic spoon actually. And the plastic number 1, the peat or polyethylene terephthalate, sinks in the water. What we find is that in addition to the number 1 plastic sinking, number 6 plastic also sinks. If I push down on that, you want to get it below the water, and you'll notice that these are pretty much sinking. There's a little bit of float in that, but not much, but they are under the water. If we take, on the other hand, number 2 plastic, which is the high density polyethylene, and put that in the water, the salt water, and push down on it, you notice that that definitely is floating. And you can see I can get my fork underneath that. So I can distinguish between 1 and 1/6 and from all the others, because all the others do float in the water, in the salt water. If I were to slowly add some tap water to this solution, you'll notice that the number 1 stays as a sinking, but the number 6, the polystyrene, as I add some water and just stir up, that polystyrene starts to float. Whereas the number 1, the polyethylene terephthalate, remains at the bottom. So I can distinguish amongst those 2 by use of salt water, concentrated salt water, a saturated solution, and then adding a little bit of tap water to that. All the others will float in that, and you can try that one out. Then we can take a look at a different solution. We'll try one other, and we're going to try distinguishing them amongst number 4 and 5. And so we're going to take some rubbing alcohol, and we're going to put that into here. So I'm going to take some rubbing alcohol, and I'm going to make a 50-50 mixture of this. So what I'm going to do is I'm going to measure out a tablespoon and a second tablespoon, and to that I'm going to add some tap water. So this is now a 50-50 mixture of tap water and alcohol. And now we're going to see about, I'm going to take our number 1 again. So I'm going to remove that from my saltwater solution. And I'm going to use a polypropylene, number 5. You notice they're not vastly different in appearance. The polypropylene, which is this one, is floating, whereas the number 1, which is our polyethylene terephthalate, is at the bottom. And also try one other one, and that's our number 4, our low density polyethylene, number 4. And you notice that one sinks. So I can distinguish amongst those using a 50-50 mixture, and then if I can try as well with alcohol. So that's the whole idea behind this particular activity. Now, this particular activity will be posted online, and one of the places where it's going to be posted is in teachchemistry.org. It's an organization that is American Association of Chemistry Teachers, and this will be an activity with the lab and teacher's guide that will be available once you sign on to that site. And the activity will be free. You may be asked to enter your email address, but the activity itself will be free. So I want to thank you for watching this, and you'll note that this is an activity sponsored in part by the American Chemical Society, Protecting Our Planet Through Chemistry, and National Chemistry Week now, April's 19th through 25th. And I hope that you try to keep our planet safe and environmentally sound for the next generations to come. Thank you very much.